In today's lesson, we're going to be using our skills with variables, strings, math to build a useless trivia program. Okay. In this file, I've laid out the instructions. Basically, a theme park wants to create a program that will run on monitors for their visitors as they're waiting in line for a funhouse ride. They want us to get some user data from them and then print back a bunch of silly trivia information about them. Okay, so that's not so hard. Because we're building a prototype, we can just send answers to the console. So we don't actually need the turtle to draw anything necessarily with these. We're just looking to collect some information and display it in the console as a result. So we can use print statements to solve most of the display for right now. Okay. Comments are important. The computer doesn't read comments, but they're important in planning out any project. And so, as we've been doing, I'm going to recommend that we write them as part of our program here. So I've laid out each of the different sections of the requests. So part 1 will be a greeting section, and there's 4 parts to that. Part 2 is an email from a poet, E.E. Cummings, and that is only one part. We have an annoying child that's going to repeat their name over and over again. We have an age in seconds. We're going to do some calculation with their age. We're going to do weight calculation on the sun and the moon. And then we're going to close it out by having the user actually hit the screen or hit enter to close out the program. Okay, so what we'll do is we'll now that we've drafted each part, we don't know exactly what the code's going to be for each of it. So we can go through and we can fill out each section as we go and build this program bit by bit. So, you know, when you have a list of requests or have a prompt that you have to try to solve, this is the way you want to do it, right? We practice this as top-down design. Essentially, I could make each of these functions and call it a greeting function, email function, and handle that within inside all of it. We don't need to be as strict with this program just because it's so simple, and there's not a lot of logic or need for overlap. So we could just do it simply as keep it simple and just do it as greeting the user, and we can go from there without needing to create a greeting function, let's say. Okay, so we can get started. So for this first one is greeting the user. For this one, let's have a greeting. So we can do print, and then we can put in strings. We can put some sort of statement in there. We could just do hello. That's easy enough. Okay, and then we ask the user for their name. Okay, so if we're going to ask the user, we have to do an input statement. And then we can say, what is your name? Okay, and now we can use this, but in order to use this information, it's probably best to assign this to a variable. So at the beginning here, I'm going to do name equals input, what is your name? And then we can use that information later on. Okay, so what else we want to do? We want to do age, how old are you? So how old are you? We could do the same thing. We do age equals input. How old are you? So what we can do is we can collect, we could do it section by section, but if we're collecting all the information as part of like a initial form, it's just probably easier just to grab it all at once from the user than having to go back and forth with them. So in this case, we'll just grab it all at once. So we have how old are you? And then the last one is her weight. Just do weight input. How much do you weigh? Okay, so we have 3 variables now with all the memory saved, name, age, and weight. And now we can use these later on in parts 2, 3, 4, and 5. Okay. So let's move on right down to part 2. An email from a poet. So print their name in all lowercase and basically add on, if poet E.E. Cummings were to email you, he'd address you as, and then we'll print back their name. So who's E.E. Cummings? E.E. Cummings was a poet that only wrote in lowercase. So we're gonna mimic his poetry here with this little bit. You're like, if you're wondering about why all this, it's just one of their requests that they want a bunch of useless trivia. So maybe you're an E.E. Cummings fan. Okay. So for this one, we're gonna do a couple different things. So let's do print, and we'll print it as. Actually, we can do a couple different exercises with this. We can do a bit of fun with this one. Let's do the original request of print. And for this one, actually, I'll show you what happens, and then we can fix it. You can do if poet Cummings were to email you, he'd address you as, okay. And then for this one, all right, what are we gonna do? We can do it like that. Actually, we'll just do it like that, and then we can add in an additional statement. And how do we do that? What we can do is we can do it as a plus. There's two different ways we can do it. We can do plus, and then we can add in the name. But we don't just want the name that they typed in, right? We want to do a conversion to it, so we do something like name dot lower. Okay. We can do it like that. We can actually just do it if you wanted to do it on the next line. All right, so actually, let's run this and I'll show you what happens here. Okay, so what's your name? I'll do caps MJ. How old are you? I'm 20. How much do you weigh? We haven't dealt with anything yet, so we can do something silly. We can do a lot. We're going to try to fix that later on. Okay, if Poet E Cummings would email you, he'd address you as MJ. Okay, very good. So for this one, what actually we can do is another way to do it is to actually just do it as print. Actually, I'm going to take this line here and copy it. We can just do that. And name dot lower. Oh, we can do it as. Nope, don't want that. We can do it as a comma. I just put it in the next line so you can see it here. But I mean, I showed you before. I was doing it like that too as well. This is just so you can see it. MJ, and I'll be 20 again. There we go. Okay. So we see the two different formats on this one. If we add in the plus, it will come out as a single string combined together. If it comes out as a comma, we can do it and it'll have a little comma in there, and it'll basically tell us what it'll be as. In both cases, we're converting it to a lower. I find this way to be a little bit cleaner. This is basically printing out the string, comma, then printing out the converted lowercase of the person's entered name. So I just find the first one to be a little bit cleaner, but I wanted to show you that there are two ways we could actually do this. And I'll actually put a comment here. And actually, I'll comment this whole thing out. Whoops. There we go. And we might say alter way of printing. So we have two options there. I think we're gonna use the first one for most of this. Okay. And then we can add in another part, which is kind of cool. We can actually do another bit that will say we can actually do an uppercase version of this, right? We can practice that as well too. We can do print. But if EE were mad, he'd call you. And then what we can do is we can actually add in our plus, and we can do a name dot upper. Okay, and let's do two different versions. I'll capitalize the M and MJ, and then I'll leave the J lowercase. We'll see what happens. How old are you? 20. What you weigh? A lot. We're gonna fix that. All right. So there we have. If Poet E Cummings would email you, he'd address you as lowercase MJ. But if you were mad, he'd call you MJ. I forgot a space here, so add a space at the end of you, and they'll fix that. Okay. So we see a capitalized version where both cases are capitalized, and then we see a lowercase where both letters are lowercase. Okie dokie. Was this all set? An email from a poet. Yep, very good. And then I'm actually going to add to the comments here, address you as, we'll do a lower case name. All right, so just clarify that instruction a little bit. And then down onto an annoying child. So this one is if a child was trying to get your attention, they might do it as and print their name 5 times. So basically, think of it like a small child or a small, younger sibling if you have one, and they're not very patient. So when they want something, it would be for me, it would be like dad, 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 dad. Maybe you remember doing this yourself at one point in your life, and so we can add that little annoying bit in here, and we can do that a couple different ways. The I guess the sort of the very simple way would just be to print. A couple different solutions. We can run like a for loop, but we haven't really practiced them with text yet. So we could do a for loop for n in range, print that. We could do like that. I'll show you a couple different ways. We could just do a multiplication though, and print that out. So I can show you how the very simple way, just using a multiplication, we could solve this. Okay, and let's set up a new variable, and let's call this repeat. And we can just do repeat name. And then what we can do is set this equal to the username. So we had this up here. We had name, right? We saved that as name. So we could do name, and then we do multiplication. That's the shift 8. And then name times 5. We could do something like that. To see what would happen, we could do repeat name. We'll have to go through all this again. MJ 20. All right. If you were to were mad made. I realize I just made that mistake. Mad at you. There we go. If we were made at you, he'd call you MJ. Now we see MJ. So we can multiply a name like we did here and have it appear more than once. Like I said, you could do a for loop on this and just do like for n in range 5 and have it do print name. They would be on separate lines instead of one line. For this, we could just use a simple multiplication. Okay, and then after this, we can do, now that we have we'll get rid of this line here. Repeat name, new variable storing a 5 times version of that name. Okay, and what I might want to do is actually do, if we want to space this out, all right, how do we do that? Well, there's a couple ways we could do it, I guess, but we can maybe try adding in a space with like concatenation. We add in a space after each name and then multiply by that. Yeah, let's try that. So repeat name is going to equal name. We're going to do plus. We can add in just a space. So you put quotes, you put a space there, and what it's going to do is going to add a space to the end of name. PEMDAS should work on this, but I'm going to add in parentheses around that just to make sure. So name plus an empty space should give us the space afterwards, okay? And then we'll do times 5. So if we do a print, repeat name, MJ, okay, we see that now it's MJ, right? So we have that space there that's available to us, okay? So that just makes it a little bit better. Okay, so now we can actually go and put the rest of that statement there. So we can do another print. I'm going to get rid of print name, and we'll just do print if a small child were to try and get your attention, they might do it as, all right, and then we can add a little space, and then we can add in afterwards. We had another plus, and now we can do repeat name. All right, there we go. Okay, so we have a name printed out. You can't see it under like the little there it is there. See, we printed out a name 5 times. So now we get that annoying child done. All right, very cool. All right, now let's move on to the next one. Next one's going to be calculation of age in seconds. Okay. Okay, so for this one, we already have an age stored, right? They entered it above on line 17. So for this one, let's do some simple calculation. Let's set up a new variable because the result we want is going to be seconds. So let's just set up a new variable, seconds. And that we can do is we can add in the multiplication of it. So we'll start off with our user's age, right? And then what we can do is we can just do some simple multiplication of it. So if the person says that they are, 20, okay, well, how do you find that age in seconds? Well, we could just simply multiply it by the amount of seconds in an hour, the number of minutes and seconds in a minute, minutes in an hour, and then hours by 24 for a day, and then multiply that by 365. So, all right, so we got 60 seconds in a minute times 60 seconds in 60 minutes in an hour times 24 hours in a day times 365. Okay, and that should get us hours and seconds. Let's do print. By the time they would read this, it would be past the time, so we'll do you're over rather than you are. You're over. Now we can do plus. You're over. Actually, I don't want to do that. I want to do seconds. We'll use the variable. And then we'll tell them seconds old. Okay, let's see if this works. We'll do 20. Uh-oh, did we break it? I think I might have broke it. Hang on, bear back. Oh, there it goes. All right. I didn't break it, but I definitely know what I did. So, all right, I just printed the console 2020. And what did I do? Well, I just printed out a lot of 20s. In fact, it might even still be printing. Okay, so it was a silly mistake. What did I do? Okay, so when I did the calculations for seconds equals age times 60 times 60 times 24 times 365, this age, when entered, I told you this in previous videos, that the age being entered is going to be a string, meaning that when we added these all together, we did it as a string. So before it even printed out all this stuff, this seconds that was taking so long was actually the calculation of seconds, because what it was doing is it was storing all these 20s in seconds. It was just doing 20 times the character's 20 and then timesing it by 60. So there's a lot of 20s here. We're going to fix this error right now. Okay, so what happened? All right, so how do we solve this? Well, we don't want a number. We want an integer. So we can either, if we wrap it around the entire statement, it'll take that 20 and make it an integer. We don't want that. So what we want to do is we want to do right here. We'll do an int. We'll wrap it around age, meaning we'll convert the age that the person enters to an integer, meaning a number, and then we can actually times it by there. So let's see this happen again. 20. Concatenate string integer on line 45. Okay, so what it's saying is that we cannot add you're over seconds plus seconds. It can't. Some languages let you do this. Python, now remembering, doesn't let you do this. So we can do this as concatenate string and integer. We can do it two different ways. We can try string. Try converting this into a string. Let's do that. There we go. Okay, so yeah, Python's particular over their conversions. Python's not gonna let you just take a string and add it to a number, a variable that's a number. So we gotta walk it through it there to be very clear what's happening. That's why people like Python, is that there's no interpretation. Everything that happens is explicit. So here, seconds, we converted an integer version of that input to from 20 with quotes around it. This integer int strips the quotes around it. And then we have 60, 60, 24, 365, and then print year over, and then we take that number version of seconds, convert it into a string, and then add it with the rest of our statement here. And a fun little fact that is close to the amount of times that it was actually printing out. Let's see how many times it was actually printing out. 365 times 24 times 60. Yeah, it's a little bit less than that. It is. We had, when we originally messed up with our 20 calculation, we had 31.5 million 2 zeros that we had printed out to the console. That's why it got hung up for a second there when we made that little mistake. So that's been fixed now with our conversions, and we're ready to keep moving. We're not going to make that same mistake again on the calculation of weight on the moon and sun. Okay, so let's get into it. We're going to make 2 calculations. Weight on moon. Let's start with that one. We want to print out a final result of moon weight, so let's set up a variable, moon weight. And the moon weight on the moon, I looked this up previously, is 1/6 of the weight on Earth. So we could just do something simple as weight divided by 6, and that will give us the weight on the moon. And then we can just do a print statement. But see, I almost did it again. We almost divided a string by that. That would have been good. Okay. Could we solve, the other way to solve for this, I suppose, is up at the inputs, wrapping each of these with integer or string, depending on what we wanted to use with it. So we're into it now, so we'll just continue on. But yeah, you could wrap it, you could convert it as soon as the person enters that information, or later on when you're going to use it. So it depends on how you're going to use it in your program. If you're going to use it as a string and an integer, both in your program, it probably makes more sense to convert it when you're using it. If you're going to use it consistently the same way throughout your program, it probably makes more sense to do it once at the top, so you don't have to convert it every single time, and then you forget and your program crashes and everything else. So let's finish up the statement. Let's do the moon weight statement. Let's do print. And did you know that on the moon you would weigh only, and then we can add in our string conversion, string of moon weight, plus we can do pounds. Okay, that should work. We'll give it a test once we finished up the sun weight. And I looked this up before, and on the sun, you are actually 27.1 times heavier. So we can do print on the sun, you'd weigh. I can get ready for that. And then we can do a string type conversion of sun. I can't type. Sun weight plus pounds. Okay, and then I can get a little funny here. We can do pounds, but not for long. There we go. Okay, so pounds, but not for long. There you go. So we have our sun weight, and we have our user weight. Okay, very good. And last thing is, let's wait for the user to press enter key. We're going to kind of trick them. And in computer programming, when you're designing solutions for people, you don't the user experience doesn't need to be exactly what's happening. So really in the console, any key you hit will work, but for enter, it's going to be just something people are used to and expected, so we can run with that. So for that, we're just going to check for an input. And then what we can do is we can do press the enter key to exit. Okay, let's clear these extra lines down here. All right, let's do a test. What is your name? I'll do it uppercase and lowercase so we can take a look and see. How old are you? How much do you weigh? We'll give it 185. All right, let's take a look. Okay, if E. Cummings were to email you, he'd address you as MJ. But if you were mad, he'd call you MJ. If a small child would try to get your attention, they might do it as MJ, 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 MJ. Okay, so we see the continuation of the lowercase version of that. And you could either add in an upper or lower, depending on what you want to do with that. It's just using the conversion that we did of the repeated name here. Oh, no, actually, sorry, excuse me. Yeah, so this is my original one I entered. It was the uppercase and lowercase. You can convert that if you wanted to make it a little more dynamic. Then we have you're over that many seconds old. Do you know that on the moon you would weigh only 30 pounds? Not bad. On the sun, you'd weigh 5,000 pounds. Pretty bad. But not for long. That's worse. Okay, and then we see our press enter key to exit. And if we press enter, we see that it exits the program. The cursor moves from the end of that line down to the next line. You'll see a yellow arrow indicating that we can now type things directly into the console to interact with our program as a command prompt. But yeah, so that's how we get our useless trivia program for our park that wants to entertain their guests. I don't know. Do you think this would entertain the guests? I think they'd be pretty annoyed with the end of it. But it goes through all the different conversions we've been working with. Uppercase, lowercase, inputs, math. We did some math. We did multiplications. We did additions by adding the seconds and the strings. We added these concatenation, our combining. We did our division. Okay, and we just checked for user input and reassigning variables throughout. So there's a lot here, but this covered a lot of the skills that we have been talking about beforehand. And so I wanted to give you a chance to practice those skills other than just simply learning them in the context of here's what, here's Python can do multiplication. To actually see it, how we can create a not a long program, 65 lines, but a simple program that gets to test out those skills. So I hope you enjoyed it. I'll see you in the next one.